Alright guys, so these are the ones that have to do with linear and angular momentum. So these equations, you need to, well, you don't need to know them, but you don't know which one it's asking for. So linear speed is the one that requires a little bit more work, and so linear speed here would be s divided by t. It look like an s, okay, and s is equal to r theta over t. So that's going to be the thing that you do need to remember, because the equation they give you is just this one right here, okay. So, and theta over t is angular speed, which theta in both cases has to be in radians. Okay, so excuse me. We're gonna go over these two problems right here. So the second hand of a clock is 10.2 centimeters long. Find the linear and angular speed of the tip of the second hand. So we have a clock, and this thing is going to be ticking, 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 moving this way. So if I want to find, let's find the angular speed first. That is the angle divided by time. So it doesn't give me an angle here, but I have to read into it. This is going around the entire clock. So one entire clock is 360 degrees, or 2 pi radians. And really, this is the one I'm looking for. It's a 2 pi radians, because that is how far it moves. So this is 2 pi radians divided by time, which they didn't tell me a time, but it's a second hand, so it is moving around the entire clock, so it takes 60 seconds. So 2 pi divided by 30, I can reduce this to pi over 30 radians per second. Okay, now the linear speed is equal to r times theta over t. And I know that the radius is 10.2 centimeters. And the angle is, 2 pi. And the time, is in radians, is 60 seconds. So here, 10.2 times 2 would be 20.4 pi divided by 60, and then this is centimeters per second. Okay, and so I can go ahead and plug this. If this is a calculator problem, they're going to want to know what this actual number is, so I'm going to go ahead and plug that in. So 20.4 multiplied by pi divided by 60, which is 1.06 centimeters per second. Excuse me, guys, I gotta let the dog out. Sorry about that. So another example here, compact discs have replaced the phonograph record. Well, you know what, let's do another one. Let's do this one down here. This is a little bit easier numbers. So a small pulley 6 centimeters in diameter is connected to a larger pulley that's 15 centimeters in diameter. The small pulley is turning at 120 miles per hour. Revolutions per minute, I'm sorry, miles per hour. Find the angular velocity of the small pulley. So angular is equal to theta over time. And so the theta is equal to, 120 revolutions. This is obviously not in radians, guys. So I need to know this conversion. 1 revolution is equal to 2 pi radians. And so when I multiply this equals 240 times pi radians. And the time here is, well, this is per minute, so 1 minute. So it's 240 pi radians per minute. Linear velocity, okay, so that is r times theta over t. So here the radius, so we're talking about the smaller pulley, so the diameter is 6, which means the radius is half of that, so it's 3. So 3 multiplied by 3 centimeters multiplied by my angle we found out to be 240 pi radians and 1 minute. So if I were to not have a calculator, these numbers are simple enough to multiply. So 240 times 3 is equal to, what is it? 0, 12, 6, 7, 720 pi centimeters per minute. And if I needed to be wanted the actual numerical value without pi, it would do 720 multiplied by pi, 2,261.95 centimeters per minute. Okay, so that's the end for this video, guys, and go ahead and keep studying, and I will see you all in class.